we are looking at several key concepts underlying hypothesis testing. And in the previous video, we walked through one of your homework problems where Willard Longcore was rolling dice. Let's look at some things that example tells us about hypothesis testing. You'll recall that we found that the inexpensive dice were not fair. We rejected our null hypothesis of a fair die. The dice are not fair. The chance of an even number is not 50-50. So what is it? What is the chance of getting an even number from these inexpensive dice? Because we know it's not 50-50. The answer to that question is, in some sense, we don't know. We don't know exactly what it is. But we can make an intelligent guess based upon our data. That guess is a confidence interval. Dr. Rask, that is so unfair. You're asking us to remember back to last week's modules. Yep. We've introduced the concept of a confidence interval as a best guess plus or minus some number of standard deviations. We don't know exactly what the unknown number is, but we're reasonably sure it's in this range. Take a minute. Can you construct the confidence interval for the inexpensive dice and their chance of coming up with an even number? Our best guess was 50.725%. For 95% confidence, we will go out from there 1.96 standard deviations, or 2 if you're not anal retentive. Standard deviation is p times 1 minus p over our sample size. Notice now p is the number we got from our data. We don't have any hypotheses to rely on here. P, 1 minus p over this many die rolls gives us a confidence interval. Basically, we're pretty sure that the chance of getting an even number on these inexpensive dice is somewhere between 50.6 and 50.8%. Don't know exactly what it is, but we're pretty sure it's somewhere in that range. Note, by the way, our confidence interval, we're pretty sure it's somewhere between 50.6 and 50.8%. We don't know exactly what it is, but we're pretty sure that it's not 50%. Notice we rejected the null hypothesis of 50% on the inexpensive dice. If you work through a similar confidence interval for the precision dice, you'll get this result, somewhere between 49.976 and 50.1 and some change percent. And once again, we don't know exactly what it is, but 50% is in this interval. It's entirely plausible that the chance of an even number on the precision dice is 50%. We are not rejecting that hypothesis. Notice there is a connection between confidence intervals and hypothesis tests. They're answering related, not the same, but related questions. A confidence interval wants a numerical answer. How often does something happen? A hypothesis test is calling for a yes-no answer. Is this the case or not? But the hypothesis test and the confidence interval will be related. Another question for you. Again, let's focus on those inexpensive dice. We've noted that the confidence interval, the chance of getting an even number, is somewhere between 50.6 and 50.8%. We're pretty sure it's not 50-50. Somewhere between 50.6 and 50.8. The question I have for you is, do you care? As you sit down to play Monopoly, does this influence your strategy? You and your 5-year-old nephew are going to play Chutes and Ladders, and of course you aim to beat the crap out of the kid because you can't go easy on him. You know that the die are slightly off of true. Does that deeply influence your strategy to show your nephew who is boss? You don't care? I will have you know that as a statistician, I find this result highly significant. Why is this highly significant? Because the word significant is a technical term in statistics. Every field has its own specialized vocabulary, and words will sometimes take on specific meanings in that context. When your economist talks about an economic rent, something is different than what your landlord means when they talk about rent. An accountant talking about a debit and a real person talking about a debit can mean rather different things. Similarly, the word significant has a specialized meaning in a statistical context. Anytime you see the word significant used in a statistical sense, it means we can reject the null hypothesis. We're pretty sure something is going on here. We're not saying it's a big something. We're not saying it's an important something. It might be, it might not be. What we're saying is it's a real something. We're pretty sure of that. Statistical significance, in common everyday parlance, is not the same thing as practical significance. However, there is one group who would find Willard Longcore's results to be both statistically and practically significant. That result is casino owners. Those inexpensive dice, somewhere around 50.7% evens. The profit margin at craps is only about 1.5%. That's half the profit margin. And that is why the casino is ponying up the bucks to buy those expensive precision dice. They find the inexpensive dice to be not just statistically significantly unfair, but also practically significant.